Okay, so to solve the problems today, you're going to be using this knowledge here about the discriminant. The discriminant is b squared minus 4ac. And remember these bits. The discriminant is positive, you get two solutions. The discriminant is 0, you get one unique solution. The discriminant is negative, you get no solutions. So positive, two unique solutions. 0, one unique solution. Negative, no real solutions. So when you see the wording on a question and it's talking about the number of solutions, you need your brain to fire and say discriminant question. So in the wording of this, it says find the value of n such that this quadratic equation has one real solution. So when you see a question talking about the number of solutions to equation, the first thing to think about is, oh, this is probably a discriminant question. And it is. We need one real solution. So what value does the discriminant have to have? 0. So one real solution implies that the discriminant equals 0. This will get you 1 mark. This will get you 1 mark. So a phrase like this, where you take the question and show what it is that you're looking for, even if you're not successful, this will get you a point, a method point. So one real solution implies the discriminant is 0. That means that b squared minus 4ac equals 0. Now b is 20, so b squared is 400. What is the value of a? 2. What is the value of c? N. So we've got 400 minus 8n equals 0. 400 equals 8n. N equals 400 divided by 8, which is 50. Okay.
How do we get 8?
What's 2 times 4?
8. Well, where's the 4 come
From the discriminant formula is always 4ac. So 4 times a is 8 in this question.
Yeah, but what happens to the x squared? It says 2x squared.
Yes, but we're using the discriminant particles of the quadratic formula.
So like the x squared would go.
No. This is a separate equation implied by the quadratic equation.
It's equals to like,
Okay, let's try another question like this one. Let's try this one. It's a little bit harder.
so only
Okay, all right. So we want to find the value of n such that this equation has no real solutions. So when we see the phrase talking about no real solutions, if you see one unique solution, 2 unique solutions, no real solutions, any number of solutions, discriminant. So we're going to use the discriminant for no real solutions. What value must the discriminant have?
it needs to be negative.
It needs to be negative. So we get b squared minus 4ac has to be negative. Let me just list up over here. What is the value of a from that equation? 1. What's the value of b? Sorry, can you stop eating so much? You've had your, I let you have your popcorn, but now you're making a lot of noise. B. What is the value of b? What's the value of c? 4. So we put these into the discriminant. We get n squared minus 4 times 1 times 4 is less than 0. We get n squared minus 16 is less than 0. We get n squared is less than 16. Give me a number that when I square it will be less than 16. 3. Another one. 2. Anything else? 1. Anything else? 0. Anything else? Negative 1. What is that? Sorry. Can we wake up? Is there any number bigger than 3 which is still less than 4?
Negative 4.
Is it bigger than 3? 3.5? Is there any number bigger than 3.5? So this inequality is tricky to solve. Remember when we're solving inequalities, we can add and subtract on either side, no problem. What happens if we multiply and divide by a negative? The inequality swaps direction, doesn't it? Now on an inequality, when you square root both sides, happens. Other stuff happens. Okay? When we square root both sides, you know we have the plus minus? We can't have this. We can't have, it can't be this. It can't be this. Because this would be n is less than plus and minus 4. It can't be this. Let's look at the number line and see why. So here's the number line. Here's 0. Here's 4. So if we have a number on the number line which is less than 4, we have that. If we have a number line that's less than minus 4, we have that. It doesn't make sense to have it. The minus 4 is irrelevant because if n is less than 4, it's got to be less than minus 4. Something's not right there. So what happens when we do this is it turns this one in on itself. It says it's got to be also greater than 4, minus 4. So less than 4, but greater than minus 4. It's going to be these numbers. And as we reason, if you think about squaring a number, if you square 0, it's not bigger than 16. If you square any number less than 4, it's not bigger. If you square a negative, it turns it positive. So it's going to be a number between minus 4 and 4. So when you take the square root of both sides on inequalities, it's a little bit harder than equations, you get this. When you square root both sides, you get that.
Is it just like a domain range thing?
Kind of, it's like a domain thing. Like a domain thing. Let me show you a few, let's try and solve a few examples. If we have n squared is less than 25, what will the answer be?
Negative 5.
Negative 5?
Is smaller than n, which is smaller than 5.
Let's try another one. If we have n squared is less than 49. Somebody else? What's this one going to be? Negative 7 is less than n is less than 7. Make it slightly harder. Let's have n squared is less than 30. Without a calculator, what's this going to be? Minus root 30 is less than n is less than root 30. An easy answer? That's it?
So if it doesn't have a square root, it's not like
You can, if it was root, if I'd chosen 20, then I would have simplified it to 2 root 5. But I chose 30 because you can't simplify root 30. I didn't want to do 30. Let me do some more. Let me do some more. All right. So let me make it slightly harder. Watch this one. This one's different. Let's say n squared is greater than 4.
negative 2 is greater than n greater than 2.
Yeah, it's harder.
2 is greater than n, which is greater than negative 2.
So yeah, this one's a little trickier. So you do it like this. This one's easy. N has to be greater than 2. N has to be greater than 2. You can just see it in the logic. What's the other one? The other one is that n is less than negative 2. And here we need an or. We have to answer it like this. Either it's less than -2 or it's greater than -2. It can't be both at the same time. So with these inequalities here, you've got your 2 points there, and our solution lies between them. With these questions that I'm going to do here, with a greater than, you got your 2 points created by your square root, and then your solutions are going to be there and there in the opposite direction. So let's try another one. Try question 5. N squared is greater than 36. What's the answer going to be?
For number 14, you write it out. N greater and is greater than plus
You have to write it as 2 separate ones. You can't do a plus minus. You have to write it like this. It's the simplest way to do it. You can answer using interval notation if you want to. You can answer this one that n is from -infinity to -2 to infinity. Anything there? Excellent. Excellent.
Why is this one or and then the other are not?
Because the other two can exist at the same time. Because look in the picture, they join. It can be greater than -2 while still being less than +2. But it can't be less than -2 while still being greater than. Look at the picture. You have an or because you have a gap. On this one, you've got one inequality pointing this way and another inequality pointing that way, and they meet in the middle, and that's fine. But on this one, you've got one inequality pointing away in that direction and another in that direction. That's why you need the or. Yeah. Greater than is the or, less than the join. It's easy. Okay, so coming back to that, we get our solution here. Now, let's visualize what these type of questions mean a little bit. So I'm saying that we get no real solutions when we get a value between these two. Nadine, can you wake up? You've got your eyes closed. And your head's dropping off to one side. Let's have a little look at what these mean visually. Our equation, where is our equation? X squared plus nx plus 4. So let me give my little slider here. I'll call this one n. So there's my n. And I've got y equals x squared plus n x plus 4. Okay, so I've drawn the function. If I make n 5, how many solutions do I have? If I want the function to equal 0, because remember we're solving the equation where this expression equals 0. It can be modeled using a function, as we saw previously. We can model it using this function, and then we look for where the zeros are. How many zeros does this have? It has 2. Watch as I make this bit smaller. Watch as I make this smaller, and here, no. How many solutions does it have now? That's 1. Anything less than 4, how many solutions do I have now? How many times does it cross the x-axis? Doesn't cross, no real solutions. And it goes up until I get to 0. And then it starts to come back down again. Watch it coming back down. And at -4, it's going to touch it once, and then it's going to cross and give me 2 solutions. That's how these look. And that's how the varying values of n create the number of solutions.